how it feels when no one's around. I get kinda lost and I can't see straight. Hate it, but it's just what we take.
Good morning, everyone. This is Group 3, the Nanomasters. Our lesson for today is nanotechnology materials.
So first, what is nanotechnology?
Nanotechnology is a common word these days, but many of us don't realize the amazing impact it has on our daily lives. According to the United States National Nanotechnology Initiative, nanotechnology is a science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. 1 nanometer is a billionth of a meter, or 10 to 9 of a meter.
Materials are regrouped into 3 main areas.
The raw materials,
The nanostructured materials
and the group composed by nanotubes
and fullerenes. The raw materials includes nanoparticles and nanocrystalline materials that are readily manufactured and substitute for less performing bulk materials.
Nanostructured materials are typically processed forms of raw material that provide special shapes and functionality.
Example of nanostructured materials are quantum dots and the dendrimers.
Nanotubes and fullerenes can produce materials that are 100 times stronger than steel, more conductive than copper.
Nanoparticles are of great scientific interest as they are effectively a bridge between bulk materials and atomic or molecular structures. Nanoparticles exhibit a number of special properties relative to bulk materials.
The interfacial layer typically consists of ions, inorganic and organic molecules. Organic molecules coating inorganic nanoparticles are known as stabilizers. Capping and surface ligands are passivating agents.
Nanocrystalline materials. Nanocrystalline materials are polycrystalline materials with grain sizes up to 100 nanometers. Because of the extremely small dimensions, a large volume of fractions of atoms is located at the grain boundaries, and this confers special attributes to the materials. Nanocrystalline materials exhibit increased strength or hardness, enhanced diffusivity, improved ductility or toughness, reduced density, reduced elastic modulus, higher electrical resistivity, increased specific heat, higher terminal expansion coefficient, lower terminal conductivity, and superior soft magnetic properties in comparison with conventional coarse grained materials.
A part of nanoparticles, the quantum dots, are man-made nanoscale crystals that can transport electrons. When UV light hits these semiconducting nanoparticles, they can emit light of various colors. These artificial semiconductor nanoparticles that have found applications in composites, solar cells, and fluorescent biological labels. The properties of a quantum dot are not only determined by its size, but also by its shape, composition, and structure, for instance, if it's solid or hollow.
Dendrimers. Dendrimers are synthetic three-dimensional macromolecules formed using a nanoscale fabrication process. A dendrimer is built from a monomer with new branches added in steps until a tree-like structure is created. A dendrimer is technically a polymer.
Dendrimers are nano-sized, radially symmetric molecules with well-defined homogeneous and monodisperse structure, and that has typically symmetric core, an inner shell, and an outer shell. Dendrimers are just in between molecular chemistry and polymer chemistry. They relate to the molecular chemistry world by virtue of their step-by-step controlled synthesis, and they relate to the polymer world because of their repetitive structure made of monomers.
Nanotubes are a sequence of nanoscale carbon atoms arranged in a long thin cylindrical structure. They are related to two other carbon crystal forms, graphite and diamonds. They are often described as looking like rolls of graphite chicken wire, but as member of the fullerene family, they are essentially bacubles expanded from the center into cylinders. Nanotubes are also called bacutubes in some reference books. Nanotubes are proven to be useful component for nanotechnology. Nanotubes are self-assembling organic or inorganic sheets of atoms, arranged in tubes with single or multi-walled structures with large internal volume. One of the most popular nanotubes is carbon nanotubes. Carbon nanotubes are graphene sheets rolled up into tubular form, wherein each layer consists of hexagonal networks. Two types of carbon nanotubes are the single-walled carbon nanotubes and multi-walled carbon nanotubes. Single-walled carbon nanotube is a cylinder formed with only one layer of carbon molecules. Commonly, these have fabricated in diameters ranging from 0.4 to 2 mm. It has three types of structures: zigzag, armchair, and chiral. It is possible to recognize zigzag, armchair, and chiral nanotubes just by following the pattern across the diameter of the tubes and analyzing their cross-sectional structure. On the other hand, multi-walled carbon nanotubes differ with single-walled carbon nanotubes by the number of cylindrical walls they have. In multi-walled carbon nanotubes, the carbon molecules form multiple concentric walls of consequentially increasing diameters around one another. Although there are numerous walls in multi-walled carbon nanotubes, each wall is composed of an atom-thick structure.
Fullerenes are pure carbon molecules composed of at least 60 atoms of carbon. Because a fullerene takes a shape similar to a soccer ball or a geodesic dome, it is sometimes referred as a buckyball after the inventor of the geodesic dome, Buckminster Fuller, for whom the fullerene is named. Fullerenes have a hollow core or empty region of space inside the molecule. Think about the basketball. It is a spherical shape made of leather, but inside is a hollow core where it occupies air to make it bounce. It's the same thing with the fullerene. It's made up of only carbon and there is always a hollow space inside the structure. Structurally, fullerenes very closely resemble graphite, which is the form of carbon found in pencil lead. Graphite is composed of sheets of carbon atoms that are linked in hexagonal rings.
Thank you for watching! Please don't forget to click and subscribe!
To say, but it helps that you feel the same. When the lights go out, we're glowing.